In this tutorial we're having a look at the theory behind literal and simultaneous equations. Okay, so what are literal equations? Literal equations have have several variables. Solutions to literal equations will be in terms of these variables, also called parameters. So an example of a literal equation would be mx plus ny equals kx plus z. Okay, so you can see we've got no numbers in there at all, okay, but we could still solve this thing for x or y or any of our variables. Okay, it wouldn't matter. Okay, we're going to look at working with some of those in the next video. Okay, when we look at simultaneous equations with two variables, okay, we'll look at how to solve some of these. Though, of course, hopefully by now, simultaneous equations with two variables hopefully won't give you too many dramas. Okay, but what we need to understand is what actually means with the number of solutions. Okay, so for simultaneous equations with two variables, no solution occurs when our lines are parallel. Okay, so we're going to have the same gradients, okay, but different constants or c values when we're talking about our form y equals mx plus c. Okay, so we're going to have the same gradient, okay, but different c values. Okay, for one solution, okay, we can have different m values. Could have the same c value, could be different, doesn't really matter. Okay, but we're going to have different ones. Okay, and we're going to intersect at that one point. Okay, and then we can have infinitely many solutions, and of course our two equations need to be exactly the same for this to occur. Okay, a little bit different when we start talking simultaneous equations with three variables however. Okay, so we've got a couple of different ways of having those solutions. Okay, so we could have our three different planes this time, because we're three variables, we're talking about planes, not just straight lines. Okay, so they could be parallel but not actually touching each other or intersecting anywhere. Okay, or we could have something like this situation here, okay, where our planes do intersect but they don't have that common intersection point. So the blue and the black one intersect, black and the red intersect, and the blue and the red intersect, but they never intersect at the same point, so we have no solution there. Okay, we have one solution, which is something like this. Really, we've got to create our x, y, z coordinates, okay, which if you like would be like in here. So we're going to have one point of intersection of all three planes right in the center there. Okay, so that's what it's going to look like if we've got one solution. Now, infinitely many solutions, we have a couple of different options. Again, just like with our two variables, we could have the planes are exactly the same. Okay, so they're all exactly the same, sitting on top of each other. But again, we could have it actually like this, where it's kind of like pages of a book, okay, attached. So we've got this line down the middle, okay, which is common to all three planes. Okay, and there's going to be an infinite number of solutions along that line. Okay, remember, it doesn't matter if that was, say, from 0 to 1. Okay, there's still an infinite number of points between 0 and 1. Okay, so that's just a little look at what literal equations are and what our solution to simultaneous equations look like. Next tutorial, we're going to do some worked examples on how to solve our simultaneous equations.